Good day everyone. Now I'm gonna write an assembly program to read two decimal numbers, then multiply them together and output the result. Let's first identify the variables needed for this program. Num1 and num2 is the first variable will be hold the values presented in the variables to be multiplied. Another variable will be holding the output or result of the multiplication is the result. And the last variables will be holding the messages enter first number to multiply, enter second number to multiply, and result of multiplication is to be printed for the user. So, data segment is the starting point of the data segment in a program, and data is the name given to this segment, and segment is the keyword for defining segments where we can declare our variables. Code segment. So code segment is the starting point of the code segment in a program, and code is the name given to this segment, and segment is the keyword for defining segments where we can write the coding of the program. Assume ds data cs code. In this assembly language programming, there are different registers present for different purposes. So here, we have to assume data is the name given to data segment register, and code is the name given to code segment register. And start is the label used to show the starting point of the code which is written into the code segment. Move AX data, move DS AX after assuming data and code segment. Still, it is compulsory to initialize data segment to DS register. Move is a keyword to move the second element into first element, but we cannot move data directly to DS due to move command restriction. Since we move data to AX and then from AX to DS. AX is the first and most important register in the ALU unit. This part is also called initialization of data segment, and it is important so that the data elements or variable in data segment are made accessible. Leia dx MSG, which means message 1, move AH9 in 21H. This three-line code is used to print string or message present in the character array till $sign symbol, which tells the computer to stop. So, Leia dx message 1. In this, Leia stands for load effective address, and it loads the effective address of second element into first element. This same code can be interchangeable, written as move dx offset message 1, where offset means effective address and move means move second element into the first element. Move AH9 int21h. This two-line code is used to print the string or message of the address present in the X register. Standard input and standard output related interrupts are found in int21h, which is also called as DOS interrupt. It works with the value of AH register. If the value is 9 or 9AH, that means print the string message of the address present in the X register. So in next line, move AH1 int21h sub AL 30h move num1 AL. This for line is used to read a character from console and save the value entered in variable num1 in its BCD form. This can be done by subtracting 30h or subtract AL 30h. The value coming from console is basically in ASCII or ASCII. Standard input and standard output related interrupts are found in int21h, which also called as DOS interrupt. It works with the value of AH. If the value is 1 or 1h, that means read a character from console, echo it on screen, and save the value entered in AL register. Sub AL 30h means subtracting 30h from AL. Move num1 AL means move value in AL register into variable num1. Leia BX message 2 or MSG2 move AH9 int21h. So this line code is used to print the string or message of the address present in the X register. So move AH1 int21 sub AL 30h move num2 AL. This line code is used to read a character from console and save the value entered in variable num2 in its BCD form. MUL num1. This line code is used to multiply the two variables and save the result in another variable. Now we have understood part of it to multiply two numbers with AL register. We can write MUL, then num1, and MUL, BL, provided the value to be multiplied is passed to BL register in prior. Now the resultant value is saved in accumulator AX for DD and for the DW. So move resultant value to result variable D instruction move result AL. So next line, A, AMM, which means in ASAP, ish, and then AM means as we adjust after multiplication. AM instruction has no operands or value attached to it. If we are multiplying two BCD numbers, the result is saved in AX register in hexadecimal form. What AAM exactly does is it converts the result into BCD form, and first digit is saved in AH register and second digit is saved in AL register. The result of multiplication is in AH and AH and AL register in BCD form after using AMM. Now we want to print the result on screen or console. The BCD form value will not show us the result, but will print the corresponding ASCII codes for the number, since by adding 30H to BCD will convert it to ASCII code, which will print the digit on screen. Then the next line is move DXAX. So since the AH register is used again and again, we cannot lose the result in AH and AL register. So to save the printed value in BH and BL register by moving AX to DX. Next is Leia DX message 3. Move AH 9 in 21. This 3 line is used to write a character on console present in BH register. Standard input and standard output related interrupts are found in int 21, which is also called as DOS interrupt. It works the value of AH register. If the value is 2 or 2H, that means write an character on console present in BL, since the value to be printed is moved to DL register. Here we are printing BH. So next line is move AH to move DLDH in 21. This 3-line code is used to write a character on console present in BL. So move AH to move DLDL in 21. This line code is used to exit the DOS or exit the operating system. Standard input and standard output related interrupts are found in int 21, which is also called as DOS interrupt. It works with the value of AH register. If the value is 4CH, that means return the operating system or DOS, which is the end of the program. So next is the code ends. Code ends is the end point of the code segment in a program. We can write just ends, but to differentiate the end of which segment it is of which we have to write the same name given to the code segment. Then the last is the end start. End start is the end of the label used to show the ending point of the code which is written in the code segment. So now we are going to emulate these codes. Here is it. This one. This one. So we're going to run it. So it will output this. Enter first number to multiply. So I'm going to enter number 2, and the second number to multiply is also number 2. Then the output of it is result of multiplication is 4. So thank you for watching, guys. I hope you have understand my explanation, and that's it. Thank you.